Everyone is talking about AI. We talk about the chips, the algorithms, the billions of dollars flowing into data centers. But there's a hidden side to the AI revolution that almost no one is discussing, a physical, tangible reality that could become the biggest bottleneck to the future of technology. It's not just about code and data, it's about the physical elements that power them. From the deep earth to the silicon wafer, the scale of this physical requirement is staggering. I recently watched a fantastic breakdown by Andre Geek about how the US is returning to Hamiltonian economics, using tariffs to rebuild manufacturing, and how countries like China are hoarding gold to create a neutral reserve asset outside the US dollar system. It's a massive macroeconomic shift. He pointed out that gold could theoretically need to be revalued to $38,000 an ounce to balance global trade. But what if I told you there's another massive catalyst driving demand for precious metals, one that isn't just about central banks, but about the sheer physical requirements of artificial intelligence? We are connecting the dots today between Andre's macroeconomic thesis and the explosive, energy-hungry world of AI sustainability. We are entering a new commodity super cycle, and precious metals are at the center of it. Let's look at the numbers. The global AI data center market is booming. These aren't your old school server farms. By 2025, a third of all new computing capacity is dedicated to AI. These servers run incredibly hot. Goldman Sachs research estimates that global power demand from data centers will jump 165% by 2030. To handle that kind of power and heat, you need materials with superior electrical and thermal conductivity. You can't just use cheap alternatives without losing performance or risking corrosion. That's where precious metals come in. Gold is essential. It doesn't corrode or tarnish, making it perfect for the high-frequency connections inside GPS. And specialized AI accelerators. The World Gold Council noted a 10% increase in demand in early 2024. Then there's silver. Silver is the best electrical conductor on Earth. It's used in high-speed connectors, multi-layer ceramic capacitors, and even the thermal management systems that keep these AI chips from melting down. As AI hardware gets denser and more powerful, the amount of silver required per server goes up. But the metals inside the chips are only half the story. The real crisis is power. AI is changing the grid. AI data centers are expected to consume roughly 22% of all US household electricity by 2025. To deliver that power, utilities have to completely modernize the grid. This requires an enormous amount of material. This means thousands of miles of new copper wiring, new transformers, and massive substations. Each new gigawatt of grid capacity requires about 5,000 to 7,000 tons of copper. And because these systems need to be incredibly reliable, they rely on silver contacts in circuit breakers and switches. This brings us to the core issue of AI sustainability. The environmental impact isn't just the electricity it uses. It's the massive ecological footprint of mining the metals required to build it. It's a difficult paradox. We are caught in a paradox. We need AI to help solve complex global problems, maybe even climate change. But building the AI infrastructure is currently putting massive strain on the environment and our natural resources. This is where the technology story crashes directly into the macroeconomic story Andre Geek talked about. Remember the economic trilemma? The US wants to rebuild its manufacturing base and protect its economy. But the metals required for this AI revolution, copper, silver, rare earths, are geopolitical pressure points. If the US imposes high tariffs on foreign goods, it could disrupt the supply chains for these critical AI materials. Furthermore, as central banks like China's hoard physical gold, they are simultaneously securing the physical commodities needed. The same metals that act as a hedge against inflation are also the critical components of the AI supercycle. So, what happens next? The supply of these metals is structurally constrained. Major new discoveries have plummeted. Major new gold discoveries have plummeted, and silver is mostly mined as a byproduct, limiting supply response. To make AI sustainable, the industry has to adapt. We will likely see a massive push towards closed-loop recycling. Ironically, mining companies are now using AI to find new deposits faster and optimize extraction. AI helping to build AI. If you are an investor, the takeaway is clear. The demand for physical precious metals isn't just about inflation anymore. It is a story about the physical limits of the digital world. The AI boom is a metals boom, period. As Andre pointed out, these macroeconomic shifts take a decade to play out. Pay attention to the commodities making it possible. Let me know in the comments. Do you think physical limits will slow AI? Comment demo for more. See you in the next one.